Hey guys, what's up? We're looking at evaluating a surface integral over a triangular region with these vertices 1, 0, 0, 0, 2, 0, and 0, 0, 2. Now we've got these points in the x, y, z space, and they're on the coordinate axes, and we connect them. And we see this triangular region, and it's actually just a plane. And we need the equation of this plane. So first, the equation of the plane. So we need a normal vector. And we need a point on the plane. Well, we've got 3 points in the plane here, so all we need is a normal vector. So what we're going to do is we're going to call these 3 points A, B, and C. And what we're going to do is create 2 vectors AB and then AC. And the way we do that, so we'll call them A, B, and C. If we take AB, a vector that goes from A to B, we can call that vector -1, 2, 0. And how do we do that? We take the coordinates of B minus the coordinates of A. And the same thing for vector C. We could do coordinates of C minus coordinates of A. So -1, 0, 2. Now we've got 2 vectors in our plane, vector AB and vector AC. Take the cross product to get the normal vector. So the normal vector is going to equal the cross product of these two. So I put an I, a J. So put an I, J, K, and take the cross product. So the cross product is going to be, let's see, cover this up, I get 4. Cover this up, I get -2, but it's J, so it's already negative, so it's going to be +2. And then cover up K, I get 0 minus -2, which is +2. So there's my normal vector, and then the plane equation is going to equal, we'll do 4 times x minus 1, so I'll just pick the first point, plus 2 times y plus 2 times z equals 0, which is really just 2x minus 2 plus y plus z equals 0. Solve that for z. We get z equals 2 minus 2x minus y. So that is our plane equation. So the surface here is z equals 2 minus 2x minus y. Now, for what values of x and y am I on the surface? Well, those are the values that are down here. So these values for x and y can be seen as, anything coming from inside this triangle. And if I describe this triangle with a type 1 region, I'll have x going from 0 to 1, and y is going from 0 to this straight line. And this line equation is actually, let's see, we have a slope of -2 and an intercept of +2, so this line equation is y equals 2 minus 2x. So that's the upper bound for y, 2 minus 2x. All right, so I've got my bounds. I know this is where I'm going to find my surface. Here's the equation of my surface. Now I need the parameterization. So S of xy be equal to, just let x and y be the parameters again, since I've already got z as a function of x and y. So z equals 2 minus 2x minus y. Right, so that is my parameterization. And here are my bounds for my parameterization. Let's take the cross product. So Sx equals 1, 0, -2. Sy equals 0, 1, -1. And now I need Sx cross Sy. So take the magnitude after I get this cross product. So cover up I get -2, which is +2. Cover up j, I get -1, which is 1. Cover up k, I get 1. And then I need the magnitude to go in my integral. So this is a scalar function, so I need the magnitude of this normal vector. So this is going to be square root of 4 plus 1 plus 1, which is 6. So now my integral over my surface of the scalar function xy ds is going to be integral from 0 to 1, integral from 0 to 2 minus 2x, xy times square root of 6 dy dx. So let's evaluate this double integral now. All right, so evaluating this integral is going to be y first. I've got integral from 0 to 1 for x, and then x times y squared over 2 from 0 to 2 minus 2x dx. All right, so let's pull the 1/2 out to go with the square root of 6. So that's going to be square root of 6 over 2 times the integral from 0 to 1, and then plug in the bounds x times, see, plugging in 0, I'll just get 0, so I'll just get 2 minus 2x quantity squared dx. Now that's going to be square root of 6 over 2, integral from 0 to 1. And if I multiply that out, that's going to be x times 4 minus 8x plus 4x quantity squared, or sorry, just 4x squared dx. And now distribute the x, so this is going to be square root of 6 over 2, integral 0 to 1, 4x minus 8x squared plus 4x cubed dx. I integrate, we get square root of 6 over 2 times, let's see, 4 over 2 is 2, so that's 2x squared minus 8/3 x cubed, sorry, x cubed, plus 4 over 4, which is 1, x to the 4, from 0 to 1. And plug in those bounds. Plugging in 1, I just get the constants that are out front, and then plugging in 0, it's all 0. So this is square root of 6 over 2 times, this is going to be 2 minus 8/3 plus 1. So that's, let's see, 3 minus 8/3 is 1/3. So this is going to equal square root of 6 over 2 times 1/3, which is square root of 6 over 6. So that's square root of 6 over 6. And that is our surface integral of this scalar function.